That's what this snake sounds like. Jormungandr, the world serpent, is said to be so big that its body wraps around the entire realm. Midgard, my ancestral homeland, maybe. But how voluminous is the world's largest snake? Well, based on God of War, it's very good, you should play it. I'm estimating that Jormungandr could be like a giant slithering cylinder, a slithander, if you will. And if he is maybe 4.5 Kratoses in diameter, then half of that would be the radius, and if you multiply that by the circumference of, let's say, our world, the world snake would have a volume internally, give or take, of 1.8 cubic kilometers. That means that the world serpent could consume the entire volume, just about, of Mount Everest. Weird how volume and size don't quite seem like they're the same thing. Anyway, that's how big this snake boy would be. Hello and welcome to another episode of Because Science Live, the show where at the end of a long week of content, I take your comments, questions, and concerns about me and my well-being in this place live off the top of my head and try to extend the nerdy conversation that we have around all of the nerdy topics that we consider. I have occasional voice of the void here, Nate. Nate?
Yep.
Cool. So, what do you got?
From Shamari Wallace, what is the best shape for a spaceship?
What is the best shape for a spaceship? Well, I think the cool thing is that in space you don't need a specific shape because you are not under the same constraints such as moving through an atmosphere or having to deal with your own weight because of the acceleration due to gravity near the surface of a planet. You can have your spaceship any shape. That's what I really like about... You know what I'm going to mention, right? That's what I really like about sci-fi shows that get it right, which is to say that your ship could be as unaerodynamic as a box, and it is a box with some thrust on it, and it is equally valid as a spaceship. Now, there's other considerations that you would want to consider. That's what considerations means. Like where you would want to put the panels that would radiate heat off of your ship so that you don't boil alive in, yes, the dead coldness of space. And if you had any armor or you had any arrays or communications or something like that, that would determine the design that you would want. Also, if you wanted to have spin gravity, you might want to have a giant drum on a spaceship like this or a torus design. So that would determine the size of your, the shape of your spaceship. But I don't think there is one best design in the way that you mean it because they're not under the same constraints that our buildings have here. You can't say like a triangle or a circle would be stronger for a spaceship because gravity and weight don't mean the same thing out there. And in here. Oddly enough. What's next?
From Grant Nick, would grayscale be fatal?
The fictional disease from Game of Thrones where you get kind of grayish scale stuff on your body. Is that fatal? No idea. I would imagine that Gur Martin is making an analogy to leprosy, which can be really bad. I mean, if you don't like pieces of your body falling off. So, yeah, grayscale could probably be fatal, and that makes me think, do you know what that makes me think of? That makes me think of a concept called zoonosis, which is when a disease or bacteria or virus that's not usually found in humans jumps over into humans because it is exposed enough to us and our biology that it can make some evolutionary leap into us. So I think, what if grayscale was this ancient dragony disease that once humans uncovered some sort of ruins or some sort of ancient burial sites, that there was just enough contact between them and the grayscale parasites or bacteria or viruses that it made a zoonosis occurred and it jumped into humans. Then it can be fatal. That's the same way that Ebola jumped into us, for example. There was a spillover, which is a fantastic book by David Quammen, and if you're interested, about zoonosis, if you're interested in zoonosis at all, read Spillover by David Quammen. It is written fantastically, and it is fantastically interesting. What's next?
From Florian Hoflamer. Hey, Kyle, what is your favorite meme?
What's my favorite meme? Growing up, I loved SpongeBob SquarePants, and I still do. So I am very happy that arguably the most, the biggest and most important wellspring of memes in the last 2 years has almost all come from SpongeBob, and sometimes two different frames in the same scene that are right next to each other. I love SpongeBob SquarePants memes. Those are some of my favorite because they get right back to my childhood. So yeah, I'm a sponge boy when it comes to memes. What's next?
From Brian Ratliff. If two objects moved away from each other, going half the speed of light, could they see one another?
That is a very technical question that I think I will get wrong. So what you're talking about, I believe, would be relative velocities. And if one object, if you're going in opposite directions, you have 0.5 c here, half the speed of light, 0.5 c here. And when you evaluate relative velocities, you would subtract these two from each other, but keeping in mind what is you want to consider positive and what you want to consider negative. So the relative velocity here would be, let's say it is 0.5 in the positive direction minus the other direction negative 0.5 c, which gives you c, which is light speed. So that tells me that if relative velocity is the only thing you are taking into account, it's probably more complicated than that, then you wouldn't be able to send a message because it can only travel at the speed of light itself and you are moving apart at the speed of light. But I'm sure I'm forgetting something, relativistically speaking. But it's a good homework problem. Do it and get back to me and let me know if I'm totally wrong. What would I be forgetting? Something, I'm sure. If it comes back up in the comments, let me know. What's next?
From Marco Chavez. Why is it so hard to get something to 0 Kelvin?
Wow. Well, 0 Kelvin, as I tried to explain in my God of War video, 0 Kelvin, no degrees, because it's an absolute unit. Look at that Kelvin, absolute unit. Come on, that's good. You know that meme? You know that meme. 0 Kelvin, you can't get down to absolute Kelvin because the absolute minimum amount of external motion that molecules and atoms could have. So this doesn't mean that the atoms and molecules don't have some internal motions inside of them. They still have internal motion, like wiggling between their parts. Let's just say, simplifying. But their exterior motions, they're wiggling in, say, like a crystal lattice or something like that. Their wiggling would be down to the very minimum. We can't do this thermodynamically speaking because, we get really, 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 really close, like nano Kelvin. But this is theoretical. This is the theoretical 0 based on what we established the unit to be. And we can't get down there because of that. It's complicated. But based on our definitions, we can't get down there thermodynamically speaking because there are, the way we would do it includes changing the system in some way, like adding and subtracting energy. And this 0 Kelvin is so that there's like none of that energy. You know what? Let's move on. I don't have a concise live answer for that. What's next?
From Joshy Mix. How does Mr. Freeze ray work?
Mr. Freeze, forget his first name, has a really cold gun that does something like what Kratos' axe does, freeze enemies or good guys if you follow the canon, completely solid, or encases them in ice, it looks like. what the gun looks like it's doing, at least in the movies.
Everybody chill, come on. You know what killed the dinosaurs? Not the Ice Age. It wasn't even close to that.
I don't know why they put that line in the movie. It's so obviously wrong. Anyway, it looks like it shoots liquid coolant. And as some of you suggested in the God of War Axe video, liquid coolant would be an even better way to cool something down than just touching something like a cold metal surface to flesh. Liquid cooling, like evaporative cooling that happens on your arm, let's say when you're really hot, evaporative cooling, your sweat kind of beads on your arm, and then it takes energy away as it evaporates, more so than it otherwise would if it was just your skin and just the air. So firing coolant and super cooled coolant at someone would really, really quickly remove heat from them, and then you could get some of those freezing properties that Mr. Freeze's gun has. Something similar is happening when you get much colder. Your internal temperature drops much faster in water than it does in air. Heat will leave your body through the water a lot quicker. I think it's something like 10 or 20 times more quickly if you're underwater. That's why if you're unfortunate enough to fall through like a frozen lake or something, you can go hypothermic in minutes. So probably has something to do with liquid refrigerant. Not maybe firing liquid nitrogen at someone or something cooler, like super cooled helium. And then it would act all weird too. But then it would be hard to make that gun because it flows up and down. What's next?
From Alan Forsant, who is Kyle rooting for in the World Cup?
Do you mean football? I'm good. I'm not rooting for anyone. I don't really care. I played soccer as a kid. I lived overseas for a while when I was a kid, and I was on a soccer team in Shanghai, China, when I was living over there. But after I came back, I'm not really interested. I follow football, American football. But World Cup, what's the internet saying? Mexico. Viva la Mexico. How about that? What's next?
From Timothy Abrams, or Abrahams, why is the sky blue, not purple?
Because of the sky is blue because of the way that light will scatter through the upper atmosphere as a medium. So when light from the sun is coming in to a volume of air, let's just be general and say that the properties of said volume of air will change the wavelength of light here and how it comes down to Earth, so it will look more bluish. Same reason why water is blue, kind of. Yeah, that's why the sky is blue. The sky could be purple if the atmosphere had different properties. I have no idea what those properties would be, but the sky doesn't have to be blue. As you can see on Mars, it's a little bit differently colored. And on Venus and different planets where we've actually imaged the sky. So it depends on the air. The air is what's making it blue, not the light itself. Although the light is what makes it. What's next?
From Pope of Nope, what changes in the body would be required for a human to be immortal?
Do you really want to live forever? Forever. I'm gonna get sued. What changes can we make to the human genome to make you live forever? I don't know. There are a lot of, in longevity studies, people who study aging, there's a lot of research going on to see why we age and how we die. One promising aspect of that research is looking at a little marker, a little signature on some of our DNA called telomeres. And they're I've heard them described as those little caps that are on the end of your shoelaces. And as we get older, those telomeres seem to add some kind of molecular baggage to our cells that indicate how old those cells should be or how old our body should be. So some research is looking into how to deal with those or cut them off or make them shorter so that we don't accrue the aging effects that we otherwise would accrue. I will say that we have done amazing things for the human lifespan just by advancing medical technology. So we've gone from, we've doubled the human lifespan as humans have existed, which is amazing. But how far can we push that? As we push it further and further, diseases that usually only affect the oldest of us are now becoming a lot more common because we're getting a lot older. That's why cancer is so prevalent now as opposed to then, because people are living longer and giving old age diseases like cancer more time to be more prevalent, which would be a major challenge if you wanted to live forever. You would have to suppress every little chance that over all the cellular reproduction that would happen as you live to 100 or 200 or 300. You'd have to suppress every little chance that a cell could divide incorrectly. That's what cancer is, and it keeps going, and it replicates and replicates and replicates uncontrollably, and it gets its own blood sources, and then it does bad things to you. So to live forever, we'd have to figure out not only what makes us age, but then how to fight all of these diseases that come with old age, that and dementia and Alzheimer's and all these things. So it's an incredibly complicated problem that I don't think just a few simple tweaks would solve. It would be a more holistic thing. The way you live, what you eat, your genetics, your medical treatments, medications that you have to take, that kind of thing. That was a long-winded answer. What's next?
From Emmett is Random. I have a question for Kyle.
Better be random.
When will Matterbeam be on the show, huh?
It's pretty random. Matterbeam is one of a cadre? Is that the right word? It's one of a group of nerds that sometimes I call upon when I need some really technical stuff. Matterbeam is very intelligent and very good at working out a lot of numbers and a lot of calculations. So sometimes I turn to them. I do not think will be on an episode of this show because it is very hard to find a way for only me to escape this place, and let alone bring someone into it. And there are other more practical concerns, like distance and time. That's all we have to say. What's next?
From Stage East Eastport. Question, why is it that CO2 is only 1% of air when there is such destruction of plants? Shouldn't it be more than 1% of air?
What? Such destruction of plants. Do you mean that because there's so much deforestation going on, you'd expect there to be more CO2 in the air because there's less plants to take it up? I don't know. Deforestation has probably had some effect on the atmosphere. In fact, I'm almost positive of that. But I'll take a different approach to your question. People, when questioning climate change, for example, say, well, CO2, carbon dioxide, is such a little percentage of the total atmosphere. How can it have this effect that you are saying? And the effect isn't even a small change in the percentage of the amount of carbon dioxide in the atmosphere can have a disproportionately large effect than what its percentage increase would suggest. It hangs out in the atmosphere and traps in heat, so even just a little bit of an increase will have a direct and observable increase in the temperature of our planet, and that's exactly what we're seeing. It's the same, methane is a very small component of Earth's atmosphere, but because of the chemistry and the physics of how it interacts with light in the atmosphere, methane is 4 times worse, I think, than carbon dioxide at trapping heat. I mean, it's worse for us, but it's better at trapping heat than carbon dioxide. So even small percentage things can make big percentage differences in terms of what our planet is doing, heat equation-wise, heat energy balance-wise. That's it. What's next?
From Bubba Hotep 01. From a purely science point of view, what other world in the solar system do you think we could experiment with regarding terraforming in order to get it to be habitable for humans?
Terraforming again. I don't know. I'll say what I said last week, is that if got really good at terraforming, going back to climate change, we should probably do something about our planet first and fast. But if you had to pick a different planet, I don't know. This is a very technical question. I don't know if you would want to start with a planet that already has a workable atmosphere that you could help get heat out of or into, like Venus or like Mars, even though Mars has very little atmosphere. Or do you not need an atmosphere so much and you want to start with what you have to do in terms of infrastructure on the ground? Then could you start with something like the moon and add an atmosphere later? I have no idea. It's going to depend on the planet in particular. It's going to depend on the economics of getting air and water and soil and biological material to these planets so that we can jumpstart some of these ecological processes. That's a very, very complicated question. I don't know if we figured it out yet. Yeah. What planet would you want to go to, though, if it was perfectly terraformed? I'll ask you that. I'd want to go to one with a really good view. Maybe float in the clouds of maybe float in a Venusian cloud city. Maybe that's what I would like. I don't know. What's next?
From Callium J, if you could choose an element of the periodic table to be able to control, which would it be?
Oh, what? If I could control any element on the periodic table, what would I control? I think the obvious answer, well, maybe it's not obvious, but the obvious answer to me is water, and therefore you could probably somehow control every single being on the planet, human or otherwise, and that would be incredibly powerful. Water is in almost everything. You could control, oh, that's super villainy. You could control water supplies. You could move the oceans around. You could displace entire populations. Imagine the things you could do if you had complete control over water. Yeah, take that, Magneto. Other than that, having control over like plutonium or uranium would make you an incredibly dangerous villain. Being able to spontaneously achieve critical masses anywhere that you wanted to. Oh, wow, think of that. That's bad. That's a free one, Marvel. What's next?
From Tabor Dickinson, if you could be a dragonborn, what would your name be?
Well, you know I speak Dovahkiin, so my name, because I know all of the words from Skyrim, would be Foos Yoda. Just because I'm a total nerd.
Foos Yoda, you say?
Yeah, and then I get shot by an arrow in the knee, which is lower because I'm short. Yoda, not me. I'm huge. What's next?
From Gladzette.
I mean, I'm bigger in here. I mean, it's like relatively speaking.
From Gladzette. Kyle, you've mentioned most cells changing every 7 years. Are there any that don't change at all?
Yeah, the cellular turnover rate is not consistent throughout your body. It's not that every 7 years all your cells kind of go like and they change, because that would sound terrible and kill you. So the turnover rate is different depending on what parts of your body you're talking about. I think it's a couple of years for like cells inside your rib bones. It's a couple of days for cells inside of your intestinal lining, because there's so much acid in there and they're dying all the time, so they get replaced all the time. So it can go from years to days, and on average, that averages out to 7 to 10 years for complete cellular turnover. But I think when I was researching this for something, I do believe there are some cells that don't turn over, I think in your heart and in your brain, because if they completely turned over, something bad might happen, or so your body would say, I imagine. Yes, although off the top of my head, I cannot say for sure if it's your heart and your brain, but I believe that those are the ones where you are right, there isn't any cellular turnover. So then the question is, where do you locate yourself, and does that make you the same person over time or not? If your brain stayed the same, but your body lost all of its cells and had them replaced over years, are you the same person? Are you just your brain? Are you just your thought process? Are you your entire body, but you seem to localize whatever we conceive of as the self in your head or behind your eyes? Egyptians had a conception of themselves, or maybe it's not Egyptians, but other cultures have had conceptions of selves that weren't located behind the eyes, located in different parts of the body. Imagine how that would feel if you didn't feel as though you were behind your own eyes anymore. And then you keep doing that and that and that and that and that, and then your sense of self dissolves, and then maybe you're your entire body. And then maybe you do change over time, over years, and you lose what you are, and you gain what you aren't, and you become something new. And I'm having an existential crisis. What's next?
From Mullock7, why do people in the future / movies think that transparent display screens and smartphone are a good idea?
Well, what's the downside? Oh, yeah, like so in a show like, I don't know, The Expanse, they have they have completely transparent phones or phone-like devices, and when they are displaying some information, as you're saying, from the other side, you can see that information, like just backwards. So it's not very private, is it? I don't think it is a technical concern when people make sci-fi shows. I think it is more an aesthetic concern. Do you know why transparent devices look cool? Because they look cool, and that's what sci-fi shows go with. They want to, when you're making a show like that, you want to give, without being very explicit about it, you want to world build in such a way that you are telling the story of the world without saying it out loud. So if you have something that looks very different from what we have, like just a transparent phone, ooh, weird, that throws our minds into the future just a little bit, so it builds the world that you're in. I don't know if this is actually the best design. I think it would mess up a lot and have a lot of privacy concerns just from the material. And where's the processor? Can you see it? Is it an invisible processor? How did they do that? I don't know. I think it's more of an aesthetic concern because for whatever reason throughout our history, we consider transparent things to be more futuristic, more techy. And so it persists throughout our media. It's the same kind of thing why aliens look the way that they do. For whatever reason, when they were first portrayed, oh, this is going to go perfectly. When they were first portrayed as big bulbous head, oh, that's not so bad. Big-eyed, alien-looking things. People, that was one of the first portrayals of them like this, and it caught on, and from then on, media portrayed them in similar ways for decades, and people started having these experiences that they would then attribute to things that look like this. But think about this. If media had latched onto a different design for the alien, the common alien, would people have hallucinated or been abducted or had these experiences? Would they have seen the same thing? I don't think so. I think the more interesting example is that we have a giant cultural unsaid agreement that this is what aliens look like. And therefore, when we have weird experiences that we can't explain, or our brains create these situations when we're sleep deprived, or we have a disorder, or we have sleep paralysis, some weird neurological thunderstorm going on in our heads, we go to something that we know, something that we can latch onto. And it just happens to be this. But if it was different, I think we would have reports of seeing different things. Anyway, that's why they don't put me on Ancient Aliens. Although I could look the part. What's next? Time for one more question?
Last question, real quick. From Norman Caesar. I came in late. What happened to the beard?
Oh, yeah. So I wanted to keep facial hair for the God of War episode because I thought it looked the part. But it started getting so though. Like I could feel it almost against my teeth, so I had to. I can feel everything in here. I can feel every little tingle and every little shuffle of things. So the facial hair was kind of getting to be enough. So next episode, I still have it. Spoiler alert. Hey. That's a good place to end, just like The Simpsons, always ended on a strong note. And that is taking shots. And that is all the time we have for Because Science Live. Thank you so much for joining me across all the things that we did this week. If you want more of me, you can check out Natural Selection, not next week, but the week after on Project Alpha, where you can vote in our very fun debate show that I do with Dan Casey. Next week on Because Science, another vlog, another main episode, another live stream. I hope you join me, and I hope you have a wonderful weekend, and be nice to each other, because this, trust me, is all we have.